Have you ever wondered if you could hold our entire planet in your hands? Not the real Earth, of course, but a perfect copy of it. This is the incredible idea behind a computer simulation. A simulation is like a very detailed story that a computer tells itself. It uses mathematics and science to build a virtual version of something real. It could be a single animal, a vast forest, or in this case, our entire world. We tell the computer all the rules that our planet follows. We tell it about gravity, about how the sun warms the land, and how water flows in the great oceans. Then, we press a button and watch this digital world come to life. It is a breathtaking endeavor, an attempt to understand our home in a completely new way. Why would we want to build such a thing? The reasons are as vast and varied as the planet itself. Our world is wonderfully complex, a delicate dance of countless moving parts. Trying to understand it all at once can be overwhelming. A simulation allows us to look at this dance in slow motion. We can pause it, rewind it, or even change some of the steps to see what happens next. It gives us a safe place to ask big questions. What would Earth be like if its orbit was different? How does a single volcano's eruption change the weather thousands of miles away? In the real world, these experiments are impossible, but inside a computer they are not only possible. They are a gateway to discovery. It is a tool of immense power and curiosity. Imagine a globe, not made of plastic, but of pure information. Every mountain, every river, every whisper of wind is represented by a number inside a powerful machine. This is the heart of a planetary simulation. Scientists feed the computer enormous amounts of data collected from satellites, weather stations, and ocean buoys. This information forms the starting point of our virtual Earth. The computer then uses the laws of physics to calculate how every single piece of this puzzle will change over time. It is like watching a billion tiny clocks all ticking forward together, creating a picture of the future. This digital twin of our world is a marvel of human ingenuity. This virtual planet is not just a static picture, it is alive with activity. Clouds form and drift across digital continents. Ocean currents swirl with warmth and cold, just as they do in our real seas. Storms gather strength over virtual oceans and make landfall on virtual coastlines. It is a mirror to our own world, reflecting its beauty and its power. By watching this digital twin, we can learn things that would otherwise remain hidden. We can see patterns that are too big or too slow for us to notice in our everyday lives. It is a new kind of exploration, not across oceans or into deep jungles, but into the very fabric of how our world works, all from the quiet hum of a computer. One of the most common ways we use these simulations is to understand our weather. Every single day, meteorologists use powerful computer models to predict what the atmosphere will do next. They create a grid over a map, and for each square in that grid, the computer knows the temperature, the air pressure, and the amount of moisture. It then calculates how the air in one square will affect the air in the next. This is how a weather forecast is born. It is a simulation of the near future. It allows us to know if we should prepare for a sunny day or for the arrival of a powerful hurricane, giving us precious time to get ready and stay safe. But we can look much further than just tomorrow's weather. We can simulate the Earth's climate over many decades or even centuries. Climate is like the weather's personality over a long period. These simulations help us understand how our planet's climate has changed in the past and how it might change in the future. Scientists can input data about things like the amount of carbon dioxide in the atmosphere. The computer then shows how this might affect global temperatures, sea levels, and the ice at our poles. It is like painting a picture of the future, one number at a time, showing us the possible consequences of our actions on a global scale. It is not just the non-living parts of our world that we can simulate. We can also create models of life itself. Imagine a virtual ocean filled with digital fish. We can tell the computer how these fish breed, where they find food, and what predators hunt them. Then, we can watch how their population changes over time. We could introduce a new predator or change the water temperature to see how the fish react. This helps conservationists understand how to protect real species in our oceans and on our lands. It provides a way to test conservation strategies without putting any real animals at risk. It is a digital art, helping us learn how to be better guardians of life. Even the land beneath our feet can be brought to life inside a computer. Geologists create simulations to understand how continents drift, how mountains are formed, and how earthquakes happen. They model the immense pressure and heat deep within the Earth. These simulations can run for millions of virtual years, speeding up geological time, so we can watch entire mountain ranges rise and fall. By doing this, we learn more about the powerful forces that shape our planet's surface. It helps us understand the risks of living near a fault line, and gives us a profound sense of the Earth's incredibly long and dynamic history, a story written in stone and retold in code. The true magic of a simulation lies in its ability to answer the question, what if? We are not limited to recreating the world as it is. We can become architects of entirely new versions of Earth, all to learn more about our own. What if the Earth had no moon? A simulation could show us. Without the moon's steadying gravitational pull, our planet's tilt might wobble dramatically. This would cause extreme and chaotic swings in our climate, where seasons could change wildly over thousands of years. Places that are now tropical paradises might become frozen wastelands, and vice versa. It is a fascinating experiment that shows just how important our silent celestial companion truly is for life on Earth. We can also use these what-if scenarios to explore our own history. One of the most intriguing possibilities is to simulate the Earth without humans. What would our planet look like today if our species had never existed? The simulation might show us a world with vast, unbroken forests stretching across continents. It might show us herds of giant mammals, now long extinct, roaming freely across the plains of North America and Europe. We could see how rivers would have carved their own paths without dams and how coastlines would have evolved naturally. It is a humbling and eye-opening journey into a world that might have been, and it teaches us about the profound impact we have had. Let's try another fun idea. What if we change the climate? We could instruct the computer to create a world that is much warmer, like it was during the time of the dinosaurs. The simulation would show us a planet with no polar ice caps, and much higher sea levels. Lush, tropical forests might grow much closer to the poles. We could then see what kinds of plants and animals might thrive in such a world. Conversely, we could simulate an ice age. We could watch as enormous glaciers advance from the poles, covering vast areas of North America and Europe in a thick sheet of ice. These experiments are not just for fun, they help scientists understand how life adapts to dramatic environmental changes. These simulations can even test solutions to real-world problems. What if we planted 1 trillion trees? A simulation could help us estimate how much carbon dioxide those trees would absorb from the atmosphere, and what effect that would have on global temperatures. What if we developed a new, highly efficient way to generate clean energy? We could simulate its deployment around the world to see how quickly we could reduce our reliance on fossil fuels. These are not just fantasies, they are vital tools that allow us to test our biggest and boldest ideas in a safe, virtual environment before we attempt to implement them in the real world, helping us choose the wisest path forward. So, what can we truly learn from building these digital copies of our world? The most important lesson is one of connection. These simulations show us in vivid detail that everything on our planet is linked. A change in the ocean currents off the coast of South America can affect the weather in Europe. The clearing of a forest in one country can impact the global climate for everyone. The simulation makes these invisible connections visible. It shows us that we live not on a collection of separate pieces, but on a single, interconnected system. Our planet is one great breathing organism, and the health of one part affects the health of all the others. These virtual Earths are also one of our most powerful tools for looking into the future. They are our digital crystal balls. While they cannot predict the future with perfect certainty, they can show us the most likely outcomes of the choices we make today. They can show us the world our children and grandchildren might inherit if we continue on our current path, but they can also show us a different future, a better one, if we choose to act. They can show us the positive effects of protecting our forests, cleaning our oceans, and switching to sustainable energy. They give us a glimpse of the possibilities, both good and bad, that lie ahead. This knowledge is not just for scientists, it is for everyone. The insights we gain from simulating our planet are crucial for governments making policies, for businesses making decisions, and for every individual who calls this planet home. When a simulation shows us the increasing risk of flooding in a coastal city, it empowers that city to build better defenses. When it shows us how a certain farming practice can restore soil health, it gives farmers a new tool for sustainability. These are not abstract scientific exercises. They provide practical knowledge that can help us build a safer and more prosperous world for all of its inhabitants, both human and animal. Ultimately, simulating our planet is an act of profound care and responsibility. It is born from a deep desire to understand our home so that we can better protect it. The Earth has nurtured life for billions of years, creating a world of breathtaking beauty and diversity. Now, for the first time, we have the ability to see the whole system at once, to understand its delicate balance, and to foresee the consequences of our actions. These simulations are a testament to human curiosity, but they are also a call to action. They give us the knowledge we need to become wise stewards of this precious planet, our only home in the vastness of the universe.